We're now going to talk about the domain of logarithmic functions and logarithmic functions in general. And so the first thing to recognize is that our default logarithmic function is f of x equals log base a of x. And our a has the same rules as our exponential. It has to be strictly greater than 0, and it can't equal 1. For a lot of the same reasons, although it's inverse in the case of it can't equal 1, because we don't know what power gave a 1 result. Well, we know what power it was, but we don't know what the base was. And if it is a 1, we can't work it backwards. So our domain here is really important. I want to just demonstrate this on the calculator. If I try and take the log of 0, so here's our log button, if I hit this, it says invalid input. It doesn't accept it. Most calculators will say that it's a domain error, and this is why. Our piece here inside of this, remember our exponential had a range that was from k and up, but it was a strictly greater than k. That becomes the domain of our exponential, and so this piece right here inside of parentheses we say has to be greater than 0. So whatever it is, x has to be greater than 0 or it goes from 0 to infinity. So whatever is inside of parentheses determines the domain. So suppose we have the function f of x equals log base 4 of x minus 3. And I want to find the domain. Well, I take the x minus 3 and I set it strictly greater than 0. And then I solve for x, and I get x is greater than 3, or in interval notation, 3 to infinity. So as long as I pick things bigger than 3, I can take the log base 4 of them. Now notice the a doesn't play any role in the domain. All I care about is what's in parentheses of my function. Likewise, if I let g of t equal log base 5 of 2x plus 3, my domain is found by taking 2x plus 3 and setting it greater than 0, subtracting 3, so that 2x is greater than negative 3, divide by 2, and we get x is bigger than minus 3 halves, or from minus 3 halves to infinity, which means for this function I actually could plug 0 in, because if I plug 0 in, I'd end up with something not 0, bigger than 0 that I'm taking the log of. And that's how we find the domain of a logarithmic function.